In this version of the person class, I have two private data members, a private string called name and a private int called age. I'm going to encapsulate both of these data members and expose their functionality in two different ways. We will provide access to the name encapsulated data member by using an accessor mutator pair, and age we will expose through a property. For the name, I'm using an accessor mutator set of methods, getName and setName respectively. You'll notice that on the getName method, my accessor, I have string as the return data type, because when I'm retrieving a value from the encapsulated data, I'm actually going to be returning that as the return value of the method. So return is set to name, that encapsulated data. The mutator method, on the other hand, uses a void return value. There is no data actually coming back. Instead, on setName, we're passing a value in. That's because we want to make a change to the encapsulated data. So I have a parameter here, a string parameter called name. Now you'll notice that my encapsulated data, name, and my parameter, name, they're both the same. How do I differentiate between them? Using a keyword, this, I can make a reference to the current class, the current instance of the class. So by saying this.name, I'm basically saying look at the class scope and find an element or a member called name. Well, at the class level is the encapsulated data member, that private data member called name that I'm making the reference to. If I use name without the qualifier this, then I'm referring to the local name reference, which is the parameter. So this.name equals name. May look a little odd at first, but this is not uncommon at all, and you should probably get used to seeing this type of relationship, especially when you have values being passed in for encapsulation reasons. The property is handled a little bit differently. Instead of creating two separate methods, I create one. In this case, I'm creating a public int called age. Now you'll notice that inside the age method, I have two separate blocks, a get block and a set block, In the get block, I provide a return value. I'm going to return age. This data type must match this data type. Since age is an int that's privately encapsulated into this class, I'm simply grabbing that value of age and then returning that as the return value of the property. On the set side, I'm doing the same sort of thing, except, remember, on the set, the data is coming into the property. Now, the keyword value represents the data that's being passed into the property. So it's over on the right-hand side of the equal assignment operator. So I'm setting the encapsulated age variable equal to the value that's provided by the user. Again, this value here is going to have to match this data type, whatever the signature of the property specifies. So that's how the property works. We've seen how to create accessor mutators and properties. Let's take a look at the implementation. Inside this main method, I've created an instance of the person class using the reference variable p. If I wanted to set a value for the name encapsulated data, I have to use the mutator method, setName. So p.setName, and then pass in the value of Mike. Then to extract that value again, I can use its accessor method or getName. p.getName, notice there are no parameters, that returns a string. So that's going to be written to the console. For the property, it's a little bit different. I'm not actually calling a set in order to make the change. Since I've used a property syntax, I simply use an assignment operator and assign a value to age. Where to extract the value, p.age, without the assignment, this is basically an expression. It represents that integer value. Please note that because C# is case sensitive, I can get away with referring to the encapsulated data using lowercase a for age, while exposing a property with an uppercase A. They actually represent two completely separate structures because of the case sensitivity of the C# language.